ओके, तो
गुड मॉर्निंग सर।
हाँ, गुड मॉर्निंग
गुड मॉर्निंग सर।
गुड मॉर्निंग, वेरी गुड मॉर्निंग। ओके, तो कल जो डेरिवेशन कर रहा था उसमें मेरे ख्याल से पूरा नहीं हो पाया, तो आज उसे पूरा करते हैं। और आप लोग आपस में डिस्कस कर लो, मेरे ख्याल से ग्रुप आपके पूरे हो गए हैं, तो एक्स्ट्रा टाइम के लिए कुछ अगर सोचा है तो हमें इन्फॉर्म कर दीजिए ग्रुप में। ओके, अदरवाइज रेगुलर क्लासेस तो होंगी ही।
गुड मॉर्निंग सर।
हाँ, मॉर्निंग मॉर्निंग, वेरी गुड मॉर्निंग। तो स्टार्ट करते हैं। कल जहाँ से छोड़ा था उसके
आप कंटिन्यू कर सकते 10 से 11।
हाँ, 10 से 11 कर सकते हैं।
यस सर,
रेगुलर।
हाँ थर्सडे को कर सकते
नो सर, थर्सडे को।
थर्सडे को सर,
थर्सडे को
थर्सडे, फ्राइडे, सैटरडे
नहीं
क्या
सर,
करें?
थर्सडे को कर सकते हैं
सर। थर्सडे को 10 से 11 फ्री रहता है, तो उस टाइम आप कर सकते हैं।
ओके ओके ओके, थर्सडे थर्सडे, बट कल तो मैं खुद मेरी दूसरी क्लास हमें इंगेज कर रखी है, कंप्यूटर साइंस की। ओके, तो ठीक है, देखता हूँ मैं। कल तो नहीं पॉसिबल है क्योंकि उनको रीअरेंज करना होगा। कंप्यूटर साइंस की क्लास 1 से 2 है, फ्राइडे सैटरडे, और कल है। ठीक है, मैं देखता हूँ। और कोई पॉसिबिलिटी हो तो बताइएगा, मैं उसमें कर लूंगा। ओके
सर, जिस दिन एक्स्ट्रा आपको लेनी हो आप बता देते तो हम लोग अरेंज कर लेते टाइम।
ठीक है ठीक है, मैं बताऊंगा। मैं ग्रुप पे ही, अब मैं सारी चीजें मैं ग्रुप पे ही शेयर करूंगा। ओके ओके, सो इन yesterday we had derived a lemma, which is lemma number 3, but due to time constraint we just not completed that lemma. So okay, so I think okay, so let us start with some formula, which is you know that what is a bj. Bj is a log of cj, and that equals to I think you might know this equals to ij log of lambda j, and plus mj, where j is varying from 1 to up to r. Okay, so this is j. So okay, so here what is your mj? Mj is defined by the formula. That formula is summation k equals to 0 to sj minus 1 to the power, this is k plus 1 divided by k, and nj and k for jk, this thing. Okay, so this is your formula for jk. What is nj? Nj is your what is nj? So here you know that what is nj is this is 0 1 0 0, this is 0 0 1 to 0 0 0 0 1, this thing, and here last term is 0, and that is 1. So this is your nj, this is upper term. हाँ, yes.
सर, जो आपने mj is equal to summation run over k is equal to 0 to sj लिखा है सर, जो -1 है वो सफिक्स में है या s के साथ है? -1
this s of j minus 1, because this is the मैट्रिक्स ऑफ, आपने बताया था कि आपकी जो ऑर्डर है दैट इज ऑफ ऑर्डर sj क्रॉस sj। तो निलपोटेंट मैट्रिक्स में ऑफ ऑर्डर sj मींस क्या होगा कि उस मैट्रिक्स को जब हम उसकी पावर sj करेंगे तो दैट इक्वल्स टू 0। तो हमारे पास उस वो और उसके आगे के टर्म जो होंगे sj प्लस 1, वो सारे के सारे 0 हो जाएंगे। इसलिए हमने ये जो लिमिट समेशन था, 0 टू इन्फिनिटी टर्म्स होते हैं बेसिकली लॉग के एक्सपेंशन में। तो जो sj टर्म होगा, जो कि निलपोटेंट है तो nj to the power sj this equals to 0 due to this is an important matrix of order sj. Okay, so this means कि इसके sj plus 1 sj plus 2 ये सारे जो ऑर्डर होंगे वो that equals to 0 होंगे. Okay, so this means कि हमारा जो नॉन जीरो टर्म होगा कहाँ से होगा, जीरो से लेके s j minus 1. This is s of j minus 1. Okay,
सर K1 से स्टार्ट हुआ सर, K0 हो जा रहा तो
yes बताएं.
सर k is equal to
1. Yes, you're right. K is equals to 1. K is equals to 1. K is 1. Okay, so this is K equals to 1. Thank you. Okay, so this is your formula. और हमने क्या यूज किया था, और हमने फाइंड करना था बेसिकली क्या, हमें फाइंड करनी थी जो वैल्यू दैट इज एक्सपोनेंशियल ऑफ log of cj. We have to find this value, and this equals to, in your notes yesterday I have derived, this is lambda j, this is diagonal entry because due to multiplied sj to identity matrix, this identity, this diagonal term is sj remaining as 0. Okay, this into exponential of mj. Okay, so you have to find what is the value of mj, and here what is the exponential of mj. Exponential of mj, this is equals to summation over k equals to 0 to sj minus 1 over factorial k of mj power k. Okay, this is exponential. Okay, exponential ऑफ फॉर्म. और यहाँ पर भी क्या था, यहाँ पे भी आप एक्सपोनेंशियल में आपके इन्फिनिट टर्म्स थे, बट mj आपके निलपोटेंट मैट्रिक्स है ऑफ ऑर्डर sj, इसलिए वो ट्रायंगुलर अपर ट्रायंगुलर मैट्रिक्स विद जीरो डायगोनल, तो वो आपके हमेशा क्या होती है, निलपोटेंट मैट्रिक्स होती है. ओके, तो इतनी चीजें तो हम लोगों ने कर रखा है. अब हमें आज हम स्टार्ट करें यहाँ से. ये सारी चीजें आपकी सारे फॉर्मूले बैकग्राउंड में थे जो कि ऑलरेडी आपने last class में आपने कर रखा. Okay, so here now we will take an example. Suppose हम एक 4x4 की मैट्रिक्स लेते हैं ऑर्डर 4, और उसके बाद हम ट्राई करें कि सॉल्व करके देखें किस पैटर्न का आ रहा है. तो अगर 4x4 की मैट्रिक्स एक हम लेकर उसको चेक कर लें, और अगर हमें पैटर्न समझ में आता है तो वही पैटर्न हमारा n क्रॉस n के लिए भी होगा. Okay, so we will compute our expression, then that above expression is exponential of mj. So if we compute this mj for the case of that this mj is of order basically 4x4. Basically use mj means your cj matrix means all matrix c is of order is 4x4. Okay, so this matrix, the dotted block of this cj is of 4x4 matrix. Okay, so here we have to find what is the value of this exponential of mj. So what is the value of exponential of mj? And by formula, the above formula, we know that this equals to summation k equals to 0 to sj minus 1, but here the order is sj is 4. Here what is your sj? Sj is 4. What is the value of sj minus 4 is 3. So this equals to 0 to 3, 1 over factorial k, and this is mj k. Okay, for this matrix. Okay, or you can write in this form. So हम पहले आप चाहें तो usual definition जो है, so you can write sj of minus 1. So this equals to summation k equals to 0 to 3, 1 over factorial k mj k. Okay, so you have to find this value. So what is the expression of expansion of this? So this equals to, when k equals to 0, this becomes the identity matrix plus 1 over factorial 1 of mj plus 1 over factorial 2 mj square plus 1 over factorial 3 mj cube. Okay, so this is the expression of this formula. So you have to find what is the value of identity matrix. Okay, so this is the 4 cross 4 matrix. So you can this plus you have to find what is the value of mj here, and then try to find the mj square and then mj cube. So you have to find what is the value of mj. Okay, and mj is defined by this formula. So what is your mj? So mj is this thing. So if we write here what is mj, so mj equals to here, if we write down for j equals to sj is 4, so this becomes summation 1 to 3. So there is only three terms. So here you have write down, if you putting k equals to 1, so this becomes positive 1, to 1 by 1, and j over this is lambda j, and when we put in k equals to 2, this becomes negative 1, so 1 by k equals to 2, this is nj square k equals to 2, and lambda j square when k equals to 3, so this becomes 1 by 3, and j cube over lambda j cube. Okay, so this is the value of mj here. Okay, so this is the value of mj. Okay, so you have to find the mj in terms of nj. And nj is this thing. So if j is your 4 cross 4 matrix, so what is your nj, what is nj square, and what is nj cube? Because nj to the power 4 is, this is an important matrix of order 4, because this is of order j. So this, if we multiply nj into nj square, then nj square into nj cube, and nj cube into nj, that nj to the power 4, that equals to null matrix. Okay, so here by this formula, this equals to this thing. So what is the value of nj square, and nj cube, and then we putting here, so we get this value of mj, then that matrix we can put here mj, and then mj into mj square, and then mj into cube, this thing. So here if we putting all these values, so we get exponential of this mj, and we are interested to find in which value this thing, exponential of log cj. So that equals to lambda j diagonal increase into exponential of mj. We get here from here mj, then putting here we get this exponential of log cj. Okay, so in next page, we are trying to find what is the value of nj square, nj cube, and then what is the value of mj, then putting here. Okay, so in next page, so what is nj? So nj is equals to, this is matrix 0 0 0 0, and this into is 1 0 0 0 0 1 0 0 0 0 1 0. This is your nj. Okay, so what about nj square? So if you multiplying this 0 0 0 0 with this 1 0 0 0 and 0 1, you can write directly here. Okay, so nj square, what is the value of nj square? So here this into this, so this becomes 0. Okay, and then this into second one, so the second position is 0, and this into this, so here second position is 1 1, this becomes 1, and if this multiplied by here, to here second position is 0, and third position is 0, here this becomes 0. Then we take second one, this first one is 0, and here the second entry is 0. Okay, we multiply here with here, this is 0, and if second multiplied by last one, here third entry is 1, here third entry is 1, this becomes 1. So in here this is a fourth one is 0, this becomes 0, and here if we multiply here, this is 0, this is a 0, and here fourth is 0, so 0, and last one is 0, so all entries are 0. So this is your nj square. What about nj cube? So if we multiply here into this, so this multiply here, this is 0. Okay, then this multiply in second column, this is 0 due to second position is 0, and here this is again 0, And if we multiply this is last one, so third position is 1 1, so this becomes 1. Okay, and here the fourth position is 1, here 0, this is 0, this is fourth one is 0, here fourth position is 0, and in this column fourth position is 0. Okay, if we take this 0 and this 0 multiplying by here, this all are 0. Okay, so this is your nj cube. This matrix is nj, nj square, and nj cube. So what is the value of mj? So mj is equals to what is the formula? Formula is okay. Formula is nj over lambda j minus 1 by 2 nj square by lambda j square and plus 1 by 3 nj cube over lambda j cube. So if we multiplying that lambda j, this becomes a lambda j here. So, okay, and in second one minus 1 by 2 lambda j square, and here 1 by 3 lambda cube, and we adding this. So this becomes mj is equals to if we adding and multiplying that, so this becomes a 0, and here 1 over lambda j, here minus 1 over 2 lambda j square, and here 1 by 3 lambda j cube, and second row is 0 0 1 over lambda j minus 1 by 2 lambda j square, and third is here this is only lambda j 1 over lambda j, and last row is 0. So this is your mj. Okay, so now you have to find what is the mj square. So what is the value of mj square? So here this multiplied by this, so this becomes 0. First one is 0. This multiplied by second, so here second is 0, so this is again 0. If this multiplied by third one to lambda j, so this becomes lambda j square. Okay, so this is 1 over lambda j square, and this multiplied by last one, so here this is a second and this third. When we second multiply, so this becomes if this multiplied by here, this becomes minus 2 lambda j cube, and here this again minus 2 lambda 2 j cube. So this becomes minus okay, so what is this value? Is minus of lambda j cube. Okay, now if we multiply this first one, this is 0, and if is second is 0. If we multiply this with here, third is 0, so this is again 0, and this multiplied by here, so this becomes 1 by lambda j square, so this becomes 1 by lambda j square, and here this is 0, so first one is 0, second is goes 0, and if you multiply the third is 0, and this fourth one is this is again 0, and last one is 0. Okay, so this is your mj square. Okay, so similarly you can find what is the value of mj cube. So here what is mj cube? So mj cube is if we multiply this with mj, so here this one is 0. Okay, and if we multiply this with second, so of course this first and second are 0 0 hai, to ye 0 hi hona hai, so this becomes 0. So this is 0, and this multiplied by third, so here first one is non-zero, here 0, so this is 0, and if this multiplied by last one, so here this becomes okay, so if we multiply this with the last column here, so this first one is 0 and second one is 1 over lambda cube, so 1 by lambda j, so this becomes 1 by lambda j cube. Okay, and if we multiply this with 0, so this is first and second are 0, and then third this is again 0, and fourth the first two are 0 here and last two are okay, and this is 0, and if this multiply here, this is fourth position is 0, so okay, and here this is 0. So here we get mj square and mj cube. Okay, so what is our value is exponential of mj, and exponential of mj this equals to uh, identity matrix plus mj plus 1 by 2 mj square plus 3 means 6 mj cube. Okay, so here if we trying to solve this matrix, so this equals to identity means uh, 1 0 0 0 0 and so on. So here the diagonal term, this is your mj. Okay, this is your mj square and this is mj cube. तो आइडेंटिटी मैट्रिक्स में आपके पास क्या है, आइडेंटिटी मैट्रिक्स के डायगोनल टर्म्स हमारे क्या होंगे, दैट इज 0. सो हियर द आइडेंटिटी टर्म इज 1 1 1 1. योर आइडेंटिटी टर्म दैट इज 1. ओके, और सब में इसमें क्या है, सब में 0 है डायगोनल टर्म. आइडेंटिटी में क्या है 1, तो दिस इज 1. mj पोजीशन में क्या है, mj पोजीशन दिस थिंग, दिस इक्वल्स टू 1 ओवर लैम्डा j. ओके, और किसी में नहीं है तो यहाँ पे सेकंड इज 1 ओवर lambda j, 1 over lambda j, 1 over lambda j. Okay, and then here this term is minus 2 1 by 2 and this is plus lambda j square. This becomes okay, this is 1 minus 1 1 by 2. If we multiply here 1 by 2, this becomes here 1 by 2 here, and if we're adding this 2, this becomes, this position is 0. Okay, and similarly here if we 1 by 2 mj square, here 2 lambda j square, if we adding this term, this position is 0, so this position is again 0. Okay, and here this last position is 1 by 3 lambda j square. So this position is 1 by 3 lambda j cube, this position. And here this position is 1 by 2 minus of 1 by 2 lambda j cube, because we have multiplied by half in this matrix. This is 1 by 2. And mj cube, this position is 1 by 6. So here plus 1 by 6 lambda j cube. So denominator is 6 lambda j cube. And here this becomes 2 minus 3 and this is plus 1. Okay, so this is 3 minus 3, that equals to 0. Okay, so this means this position is again 0. So if we solve this by using these three matrices mj, mj square, mj cube, by using this formula, you get exponential of this equals to this thing, and remaining terms are of course 0. So you put here 0 0 0. So this is your matrix. This is your matrix in which only this diagonal element, which is non-zero, that is 1, and this second, this is non-zero, other are 0 0. Okay, so here finally you get this value, exponential of mj. Okay, so okay, so in next page, what is the value of exponential of log cj? So in next page, so computing exponential of mj with dimension that is higher than here we take 4. This gives the same structure, therefore exponential of mj, this equals to your diagonal terms of lambda j, lambda j, lambda j. Okay, so here if we take of a higher dimension, so this means the diagonal term is lambda j of order n cross n. This is your diagonal term into exponential of mj. So here we can write directly what is the value of exponential of that. Okay, So yeah, okay. So we can write this thing. Therefore, this equals to, here we take diagonal term is 1, and the second is 1 by lambda j, 1 by lambda j, 1 by lambda j, and so on. Here, this position is 1 by lambda j. This is your matrix, and remaining are zeros. Okay, so this is the structure of exponential of mj. So what about the value of this exponential of log cj, exponential of log cj? So this equals to this lambda j, the diagonal term, into exponential of mj, and exponential of mj is, the diagonal term is 1. Okay, and this is 1 by lambda j, 1 by lambda j, 1 over multiplication of that. Okay, so if you multiply this, so you get, the result is this is lambda j, and here this is 1, 1, 2, 1. Okay, and what is this? This matrix is, initially we defined this matrix is Cj. Okay, so if you multiply these two matrices, the remaining entries are zero. Remaining entries are zero here. Okay, so this is your main matrix, that is Cj. Okay, so here you can find, this is what is Bj. Bj is Ij log of lambda j plus mj. Okay, and this yields what is Cj is exponential of log Cj. So you calculate this thing. What is the Cj? Cj, what is the Cj is exponential of log Cj. Okay, and this comes from equation star. Okay, so here basically what is Cj is equals to exponential of log Cj, and here what is Bj is, Bj is in fact log of Cj. Okay, so here Cj is exponential of log Cj, and what is your Cj? Cj, log Cj is this thing. So you can write here this log of lambda j plus mj. Okay, and this equals to exponential of bj. Okay, and this means e to the power bj. Okay, so here from this you can you derive this thing. Okay, usually तो आप किसी भी लिख सकते हो कि that is x equals to yeah, x equals to something exponential of y. So you can write what is the value of y. Y की value हो जाएगी आपकी log x. Okay, या फिर हम x को भी हम लिख सकते हैं e to the power log of x. Okay, this means same thing. But here you prove this thing कि in this case, the matrix case, this Cj matrix equals to e to the power log of Cj. So you can prove that exponential of log this is same value of your Cj. So you have to prove that this is true for this matrix case. Okay, so here you finally you get your objective. So here we define, if we define the matrix B, what is matrix B? Matrix B is basically the diagonal of your B1, B2 up to the BR. Okay, where any bj is defined by the formula ij log of lambda j mj. Okay, so then what is e to the power b? E to the power b is equals to, this is okay, so this is diagonal of what is e to the power b. This becomes EB1, EB2 up to EB BR. And basically for any J, in any J, your Cj equals to e to the power Bj and J equals to 1 to R. This means e to the power B1 equals to C1, e to the power B2 equals to C2. So this is equals to, you can write diagonal of C1, C2 up to CR. Okay, and this is your main matrix C. Okay, so this is your main matrix C, diagonal of this C. Okay, so here you prove that basically e to the power B equals to C. So your objective is you have to find that matrix, constant matrix that equals to exponential of B matrix. Okay, but here you know that this matrix B is not unique uh, because due to clearly this B is not unique because the exponential of B, if you write plus some I 2 pi some integer m, okay, with identity matrix, suppose in, so B be the your matrix of order n, and if this is your I 2 pi m be the scalar one, and this multiplied by identity matrix, so this becomes a whole matrix. Okay, so this can be written as this equals to e to the power B multiply e to the power 2 I 2 pi m and identity matrix. And identity matrix you can write here e to the power exponential of identity matrix is same as identity matrix. Okay, and what is the value of exponential of this real one? So here you know that exponential of that equals to 1. Okay, so this equals to e to the power B e to the power I 2 pi m. If you multiply identity matrix with this, so this is same matrix, and this equals to e to the power B. Okay, so here you see that if exponential of B I 2 pi m identity matrix, this is same value as e to the power B. This means this is true for here m be any integer. Okay, so this means if exponential of B, this means if your exponential of B is this constant matrix C, and you consider another matrix that is if you define by B cap, and this B cap is B plus 2 pi I m with identity matrix. If we take this thing, so here in this case e to the power B cap, this is e to the power B plus 2 pi I m identity matrix. This same equals to e to the power B, and this is equals to constant matrix C. Okay, so this means this B matrix is not unique matrix because this B e to the power B is also C, and here e to the power B cap be the another matrix B cap. This is also equals to that C. Okay, so this means here B is not unique. So any integer multiple, if we multiply any integer matrix with 2 pi I with identity matrix and adding your original matrix B, so you get another one. Okay, so for m is taken value 1, 2, 3, 4, and so on. So here your B cap, B1 cap, B2 cap, B3 cap. So there are so many matrices you can find that satisfies this condition. Exponential of that equals to constant matrix C. Okay, so basically this one is your lemma, in which your lemma says that if C is a non-singular matrix, okay, then there exists a matrix B. There exists a matrix B such that exponential of that matrix equals to this thing. Okay, तो कम से कम एक मैट्रिक्स तो होगी ही फॉर एवरी नॉन सिंगुलर मैट्रिक्स के लिए, और एक ही नहीं होगी, एक से ज्यादा भी आप बना सकते हो by using this formula. आप कोई भी इंटीजर m की वैल्यू चेंज करते जाओ, आपके पास तो सारी की सारी करस्पॉन्डिंग एक नॉन स्टूडेंट मैट्रिक्स करस्पॉन्डिंग आपको एक मैट्रिक्स तो मिलेगी ही भी, जो कि एक्सपोनेंशियल ऑफ b इक्वल्स टू दैट कांस्टेंट मैट्रिक्स थी। उसके अलावा भी आपके पास कई मैट्रिसेस आप फॉर्म कर सकते हो। तो दिस इज द मेन जिस्ट ऑफ दैट लेमा। ओके, so in next page we go on the main theorem, that is our locate theorem. Okay, so next page.
सर सर इसमें जो एमजे हमने 4x4 मैट्रिक्स ली है,
हाँ हाँ
तो उसको हम
हाँ,
लोअर
बताइए,
ऑर्डर में हम ले सकते हैं उसे, और 3x3 या 2x2 पे?
बिल्कुल 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 ले सकते हो। हम तो 4x4 में इसलिए लिया है ना कि थोड़ा क्यूब तक हम आपको दिखा सकें कैलकुलेशन। ओके, और कोई बात नहीं थी, क्योंकि जनरली क्या होगा ना कि जब आप 3 का लेंगे, फॉर एग्जांपल एसजे अगर आप सपोज 3 ऑर्डर के लिए लेते हो, तो होगा क्या ना कि उसमें आप जब एक्सपोनेंशियल फॉर्म में जाओगे तो वहां पे आपको सिर्फ 2 ही तक जाओगे। तो वहां पे 1/2 ही रहेगा। फैक्टोरियल का बहुत यूज आपने किया नहीं, क्योंकि लॉगरिथमिक में भी 1/2 होगा, यहाँ 1/2 होगा एक्सपोनेंशियल में। ठीक है, तो फिर आपको थोड़ा सा कंफ्यूजन होगी ना कि इसमें तो 2 2 हो गया इसलिए कैंसिल हो गया। हो सकता है कि वहां फैक्टोरियल 3 हो रहा हो और यहाँ पे तो 3 ही होगा, तो हो सकता है कि शायद वहां पे कुछ और कन्फिग्रेशन आ सकते हैं, इसलिए हमने 4 लिया। और कोई बात नहीं, आप चाहें तो 5 ले लो, 6 ले लो, कैलकुलेशन बढ़ते जाएंगे। ठीक है, क्योंकि जो ऑब्वियसली है आपको उतना मेहनत करनी पड़ेगी आपको। अगर आप SJ5 लोगे तो आपको 4th ऑर्डर तक निकालना होगा, समझ रहे हैं? नीलपोटेंट मैट्रिक्स भी NJ³ नहीं NJ4 निकालना होगा, समझ रहे हैं? तो आप फ्री हैं, आप फ्री हैं। आप चाहे, आप अगर प्रैक्टिस करनी हो तो आप 3x3 भी कर लो, आप 5x5 भी ले लो, आप कम भी कर सकते हो, ज्यादा भी कर सकते हो। ठीक है, लेकिन अब एकदम 2x2 मत लीजिए, क्योंकि फिर उसमें आपकी तो सिर्फ जो इम्पोर्टेंट मैट्रिक्स 2 ऑर्डर की हो जाएगी, समझ रहे हैं? तो इसलिए हमने थोड़ा की कैलकुलेशन बहुत लेंदी भी ना हो और थोड़ा सा फैक्टोरियल का और लॉगरिथमिक एक्सपेंशन में वहाँ 1/3 है या 1/3 है, तो फैक्टोरियल के रोल में भी हमारे रिजल्ट सेम आ रहे हैं, इसलिए हमने उसको 4 ऑर्डर कर लिया। हम 5 भी ले सकते थे, 6 भी ले सकते थे, पर उसमें क्या होगा कि पूरा एक टर्म निकल जाएगा कैलकुलेशन में, इसलिए हमने 4 पे ही रिस्ट्रिक्ट किया। तो आप चाहे तो 3 पे कर सकते हो। ओके, ठीक है, चलिए। तो नेक्स्ट इज what is locate theorem? So definition, treatment of locate theorem. So the fundamental matrix mx of your locate system, which is y prime, this thing, with the condition this when x equals to 0, your fundamental matrix when putting x equals to 0, this becomes identity matrix. Okay, this has a locate normal form, and that normal form is the fundamental matrix that equals to qx exponential of bx. Okay, so what is qx here? So where this qx, basically this belongs to your C1R is T periodic, and the matrix that is B, this is of order n cross n, and that satisfies the equation that is C equals to mt, is a periodic, Okay, and this C is equals to your this matrix B. This equals to exponential of B T. Okay, so here we have this Q of 0, because if you put in here 0, this becomes M0 and this is 1. Q0 equals to M0 and M0 equals to identity matrix. So here Q0 is identity matrix and this QX is an invertible matrix. Invertible matrix for all X. Okay, so this is the statement, and here the proof. So here we write directly the result by lemma 2. From lemma 2, there exists a non-singular constant matrix, that is C, with, you know that from lemma 2 you have already proved that this for T periodic, this equals to mx into C. Okay, and here you C is basically a constant matrix. So since C is a constant matrix, so we can compute by taking this x equals to 0. So we have C, basically C at x equals to 0, and this equals to, what is this value is when x equals to 0 is, this is empty and this is M0, and M0 be the identity matrix. So if this M0, so this M be the fundamental matrix. So here this inverse exists. So M inverse at x equals to 0, and here empty when putting x equals to 0 here. So we get this C, this is C at 0. Okay, means Cx that equals to x equals to 0 to find this relation. Okay, so if we take the initial condition, and that initial condition is when x equals to 0, your M0 becomes identity matrix. Then what is C? So what is C is when you're using initial condition. So M0 is identity, so M inverse is also the identity matrix, and then multiply both, the C equals to empty. Okay, so this is your result, C equals to empty. Okay, and now from lemma, from third lemma, so here from lemma 3, you have already proved that, from lemma 3, this C, there exists a constant matrix P such that C equals to your that matrix. So C equals to your MT, that equals to e to the power, what is the function here? This means B of T for some matrix B, for some matrix B. Okay, so in next page, if QX, if this is normal form, if this QX equals to, mx equals to this thing, so this means we can write here this qx equals to mx e to the power minus bx. Okay, the exponential matrix is this. So if you pre-multiplication by this inverse, so because this is a non-singular matrix, this is also non-singular matrix, qs is also invertible matrix. Okay, so that's why this is also your invertible matrix. So in next page, if this qx can be written is mx e to the power minus bx, then for all x, this qx plus t, this equals to, here we putting here x plus t, here e minus b x plus t here. Okay, so this equals to mx plus t you have already uh, by lemma 2 you can already prove that this mx plus t equals to mx into constant matrix C. Okay, and what about this is e to the power minus bx and e to the power minus bt. Okay, so this is since m of x plus t, that is mx with constant. Okay, so you can write this thing. Okay, so now this equals to mx, and here you know that this c is e exponential of bt, so here e of bx e to the power bt. Okay, so here you can write the c is by lemma 3. Okay, so this equals to, if we multiply this matrix, this equals to bx. Okay, and this is your basically qx by the normal form, look at normal form. Okay, so that's why you here you find x plus t that equals to qx. Okay, so if we write in this look at normal form, your matrix qb the t periodic. Okay, so this means that here this means that this is this implies that uh, okay, so you write directly, this means that your mx that equals to uh, qx e to the power bx, from this mx equals to this thing where this q is t periodic. The matrix is q is basically q periodic, and this normal floated form is this thing. And you have to also find what is the value of q at x equals to 0. So when we put in q at x equals to 0, so this equals to m0 and e to the power 0. So what is the value of q0 when putting x equals to 0 here? This is e to the power 0. So this is equals to simply m0. And what is the m0 is initial condition. This is the identity matrix. Okay, so this means q0 is also identity matrix, and the matrix, this exponential of px is invertible for all x, because exponential of square matrices are invertible. This is the result basically. Every exponential of a square matrix are invertible. Okay, and this mx is invertible. So therefore, your qx is also invertible matrix. Okay, so finally, this is the result of your Floquet theorem. Okay, so here the main what is the main result of this Floquet theorem? We can write some remark. We write some remark of this Floquet theorem. So in next page, the fundamental matrix say mx that satisfying our condition, that is mx plus t, that equals to mx with constant matrix C, where our constant matrix C is obtained by MC inverse MT. Okay, so this is the formula how to find this matrix C. Okay, so this constant matrix, or this matrix C is known as, constant matrix C is known as the monodromy matrix. This constant matrix is known as monodromy matrix, and the eigenvalues of the monodromy matrix is called the Floquet multiplier of the system, and that system is defined by this y prime that equals to axy, and this is the Floquet system. This means that this A be the T periodic matrix. Okay, and second result is the eigenvalues of the matrix this B of the Floquet normal form, that is what is your Floquet normal form is this fundamental matrix written as this qx e to the power this bt. Okay, so I think bx, this is bx. Okay, so this is your fundamental form, and this eigenvalues of that matrix B are called the Floquet exponent of the system. Okay, so here since the monodromy matrix is means this matrix C and this C with the non-singular matrix. So since this monodromy matrix that is C is non-singular, this is non-singular, so its eigenvalues are non-zero. Okay, due to this C is non-singular, so therefore non-zero. Therefore, we can state the following. So if lambda 1, lambda 2 up to lambda n be the eigenvalues of this monodromy matrix, so we call this eigenvalues are Floquet multiplier. So if lambda 1, lambda 2, lambda n be the Floquet multipliers, and suppose the eigenvalues of this matrix B is suppose mu1, mu2 up to mu n, and these are the Floquet exponent.
सर ये सर जस्ट अबव लाइन में सर यहाँ पे वी कैन स्टेट द वहाँ पे फ्लोकेट्स क्या लिखा है सर? नहीं समझ में आ रहा है सर, वो वर्ड नहीं समझ में आ रहा है सर वहाँ पे.
Following.
ओके सर.
Okay, following. Okay, so let if this eigenvalues of this matrix C are denoted by lambda 1 up to lambda n, and this eigenvalues is known as of this Floquet multiplier, and the eigenvalue of this is known as the Floquet exponent. तो if this इसके eigenvalues अगर mu1 mu2 up to mu n हो, okay, तो उनको हम कहेंगे हमारे ये जो है with the Floquet exponents, with Floquet exponents for our given system, that is y prime equals to axy, where a be the t periodic. Okay, so then we can write क्या आप लिख सकते हो, our all this Floquet multiplier of suppose lambda j, that equals to mu j of t for all j equals to 1 to n. Okay, so this is one result. This is one result, and second result is second result you can write here. Okay, sorry. Okay, so next page, मेरे ख्याल से यहाँ कुछ गड़बड़ हो गई. Okay, so what is lambda j? Lambda j is mu j, no exponential of that. Okay, so lambda j equals to e to the power mu j t, e to the power mu j t for all j equals to 1 to up to n. Okay, and there is one more remark. We can write next page. The Floquet exponent are basically not uniquely determined. Okay, so these are the remark. अगर आपको ये देखना है तो आप ये लिख सकते हो, to see this आप क्या करो कि जैसे आपकी B यूनिक नहीं है, वैसे ये भी आपके यूनिक नहीं होंगे, ड्यू टू if we take this mu cap is 2 pi mi over t periodic, where this m be any integer, and we know that this e to the power 2 pi I of 2 pi m, that equals to 1. Okay, so what is the value of e of exponential of this cap? This equals to e mu j plus 2 pi mi over t. So this equals to e over mu j, this of t, and that is your this value, and this value is mu j t into e to the power 2 pi im, and this value is 1. So this equals to e to the power mu j t, and that equals to lambda j. Okay, तो आप ये देखें कि lambda j के लिए मेरा mu j वो यूनिक नहीं है, क्योंकि ये भी आपका सेटिस्फाई कर रहा है इस आपके फ्लोकेट मल्टीप्लायर्स के लिए, ये आपका फ्लोकेट एक्सपोनेंट है। और यहाँ पर अगर आप mu j कैप लेते हैं, जो कि इस तरह से आप डिफाइन करें, तो यहाँ पर डिफरेंट m चेंज करें, वो भी हमारा सेम लैम्डा j के लिए एक्सपोनेंट होगा। ओके, तो इसलिए ये है कि एक्सपोनेंट हमारा यूनिक नहीं होता। क्यों नहीं होता? बाय दिस रीजन। ओके, तो इतना ही करते हैं। हाँ, 5 मिनट हम आपका एक्स्ट्रा ले लिया। तो नेक्स्ट हम कल फ्लोकेट थ्योरम की हम एप्लीकेशन बताएंगे कल। ओके, कल तो मेरी क्लास नहीं है, और नेक्स्ट जब भी होगा हम आपको ग्रुप पे बताएंगे। ओके, तो आज इतना ही करते हैं।
थैंक यू सर।
थैंक यू सर।
तो आज
थैंक यू
थैंक यू सर।
थैंक यू
सर।
सर।
ओके, थैंक
Thank
यू
you,
टू
sir.
ऑल ऑफ यू।